concept of resonance in an RLC circuit is something we are very familiar with and have done a lot of problem solving in our earlier classes. The series as well as the parallel RLC circuit has a distinguishing property of resonating at a specific frequency known as the resonating frequency. Parallel RLC circuit is a dual series circuit in the voltage and current exchange roads, hence has a current gain rather than the impedance. The total impedance is calculated when R is parallel to ZL, which is parallel to ZC, where ZL and ZC are the impedances of inductor and capacitor respectively. When XL is equals to minus XC, omega naught comes out to be root of 1 by LC, and then the current gain can be calculated as shown in the slide. The given slide shows that how the graph looks like and the peak corresponds to the resonating frequency. But we are familiar with all these problem solving part, so let's see its practical application in a radio tuner. A radio tuner is a system which receives and converts the selected carrier frequency into a frequency suitable for processing. Its most basic structure consists of inductor, capacitor in parallel, and either of them is variable. Information is sent in the form of electromagnetic radiations wherever we go. Be it television broadcasts or Wi-Fi signals, each broadcast has a distinct frequency. The attenuation and filtering out of appropriate signals is the job done by the tuning component of radio, after which it sends the signal to the part of the device where it can be converted into a useful information. Band-pass filters are associated with these tuning components. It allows the specific frequency and attenuates all the extra ones. It comprises of low and high pass filters which isolate the desired frequency. Here is how a normal band pass filter circuit looks like. The cutoff frequency for the low pass filter is given, which is given by the formula Fc low equals 1 upon 2 pi R1C1. Similarly, the cutoff of high pass filter is given, and the region of frequency in which the band pass filter allows the signal to pass is known as the bandwidth, which is given by the difference of Fc high and low. Now let's get into the details of how we obtain these results by considering another diagram. The diagram given is a simple RLC bandpass filter. The filter functions much like a voltage divider with two impedances Z and Z2. Z is basically the combined impedance of L1 and C1 which are connected parallelly as shown in the figure. The output of the voltage divider is equal to the voltage drop across Z or the tank circuit, which is equals to I into Z. Now let's analyze the complete radio tuning process. Radio transmitters convert sound information into electromagnetic waves and convey those waves across great distances. Radio receivers must detect those signals, convert them back into sound, and then amplify them for waiting ears. The radio receiving circuits consist of antenna, which indiscriminately captures all the radio waves, radio frequency amplifier, which amplifies the current transmitted by antenna so that it is easy to tune, the tuner, which filters signal captured by the antenna, passing on signals of the desired frequency and attenuating the undesired signals, the detector, which transforms radio frequency signals into meaningful ones, and the last one is amplifier, which increases the volume of audio signal from the detector so that it can be heard. In simple radios, the tuning circuit is often a elementary bandpass filter composed of parallel LC or RLC circuit, and the important characteristic of such circuit is their variable resonant frequency. The variable frequency is manipulated by either varying inductor or capacitor by manually changing the values of inductance or capacitances of the tuning circuit, and hence the radio listener can easily control the resonant frequency. It allows them to select the frequency of radio wave which will eventually pass through the tuning circuit, which in turn determine from which radio station we wanna hear our favorite song.